between A and B and B and C. Now you are asked to match the column which says that for which of the following combination it is correct when E1 is 0.5 and E2 is 1. So how will we approach this question? So the basic approach would be conservation of linear momentum. So we have a mass 2m which is moving with 2u, and we have a mass m which is moving with u, and then a mass m which is at rest. Okay, so if we apply the conservation of linear momentum for the first time, you can say that 4mu plus mu is equal to, after collision of the first two particles, let's say this will have a velocity v dash and this will have a velocity v double dash. This is the mass m and this is mass 2m. So you have 2m v dash plus m v double dash. So now since m is common in all the factors, we are going to strike off the m from all the phases. So you're getting a 5u over here. So let's simplify it further to write a 5u over here. So now to relate v dash, we are given the coefficient of restitution as half in the first case. So what you are going to do is velocity of separation by velocity of approach. So velocity of separation can be written as v double dash minus v dash, v double dash minus v dash by velocity of approach can be given as u, and this value is given as half, 0.5, right? So v double dash can be written as u by 2 plus v dash. Okay, now if you replace it in the equation that we have over here, copying it over here. So this is the equation. So you can write here 5u is equal to 2v dash plus u by 2 plus a v dash would be over here, so I'm going to replace it with a 3v dash over here. Okay, 3v dash. So if you now simplify it, do 9 by 2 u is equal to 3v dash. So value of v dash is coming to you the 3 by 2. Okay, just minimizing this part. So if you know that the value of v dash is 3 by 2u, so it's going to 3u by 2. You can easily find the value of v double dash, which is going to be u by 2 plus 3u by 2, which is equal to 2u, right? Okay, so now we know the value of all the velocity, that is first ball will have 3u by 2, second ball will have 2u, right? Now since the velocity of the second ball is higher as compared to the first ball, so this is going to take part in the second collision. Okay, so and since that the value of E2 is given as 1, that means it's going to be a perfectly elastic collision, and since the mass with which it is colliding is equal to the mass of its own self, therefore the velocities would be replaced. So the final velocity, let's say that is of vc, will be going to be 2u, and vb will be 0. Okay, now we also have to find the correct relation amongst the kinetic energy loss. So the kinetic energy loss would be equal to, let's say the initial kinetic energy was half 2m into v squared, that would be 2u square, and in the second case it would be plus half m u square. So you will find that this value is 9 mu square by 2. Now kinetic energy final will be half 2m 3u by 2 whole square plus half m 2u whole square. Okay, so the value will be So the value will be half 2m 9 u square by 4 plus 4 u square m. So this is, if you remove the 2 from here, and if you just make it an 8 over here, so it is going to be 17 mu square by 4. Okay, and the initial kinetic was 9 mu square by 2. So the kinetic energy initial can be considered to be as 18 mu square by 4. It is 18 mu square by 4. So if you just try to find out the loss in kinetic energy, the kinetic energy loss is nothing but mu square by 4, and velocity of B finally would be 0, and the velocity of C finally would be 2u. So this is the answer that you're going to get. So just checking out from the options, you can clearly find that you have in the first column as 2, that is, and the second column you have 1, and in the third column you have r. So 2, 1 and r, that is option C is the answer.